All right, welcome back. In our previous video, we set up our first command. We created a command class. I've made a few small modifications. I'm going to go over that right now to print out some better error messages, and I'll go over exactly how that works. So to start off here in our command class, I added another virtual abstract function called error. And error takes a standard O stream for output. So this function will get called by our game if there's an error, and I'll show you how that works. In our go command, we had to implement that, and what I did was I created this error string here. It's set initially to just an empty string. And if the room is successful, it returns true, that's fine. Otherwise, what it does is it sets an error message into this error value here. That error message is that string. It depends unknown room, and then it appends the room name to it and returns false. And when this is called, it simply outputs that error. In fact, this doesn't actually have to be this could have been handled at the more abstract level, and we might refactor that in the future so that there's always an error available, and all you have to do is insert the error into that for all commands, and we'll probably refactor that. So then here also in the player, I created a print room function within the player that prints out the current room again to an output stream that you supply. This is another way to do something similar to what we were doing here with the stream operator, but you can only have one of these. If we just want to print the current room that the player's in, this just prints out the current room. And we could actually use that here by getting rid of this. We could call player dot print room OS, except the print room actually has to be above this for it to know about it, I think. Player dot print room, yeah, that should work. See if it compiles. It doesn't compile. Why doesn't it like it? Again, this needs to be a constant. And there, that works. And so what happens now if I type in go start? That's fine. Well, go store. But if I type in something wrong like go store, it says unknown room store. And that's the error message from the go command. So each command is responsible for its own processing. And the other thing that we can do is we can move this parsing out of this. So right now, what would happen is, if we look at this eval command, if we have a bunch of commands, this if kind of construct could get quite long with doing all this parsing. Okay, so in this video, what we're going to do is we're going to go revisit our command H up here, and we're going to add another virtual function to it. And it's going to return a bool, and it's going to be called parse, and it's just going to take a string line. And so each command, possible command, is going to be responsible. And this is going to be equals 0. All right, it's an abstract. So go command needs to be responsible for that. So we're going to have virtual bool parse standard string line. And so this is our function, and down at the bottom here we'll return false. And we'll do our parsing here. And how are we going to parse it? We're going to go back to our Go command, or not our Go command, rather our dungeon crawl game, and we're going to take and grab all of this stuff here that's about the Go command, which is this. Well, we'll grab this first. We want to do, well, we're going to need to split it. We're going to need to split it. So let's go to the Go command. So we've got this line, and we're gonna split the line and create a vector of string words. All right, and we're gonna check that very first word to see if it's Go. Then we're gonna check to see, yeah, we'll check to see if it's Go. Actually, you know what? Let me pause the video and rethink this. I think I'm going to do this a little differently. Okay, this is what we're going to do. So here in command.h, we're not going to create that virtual function. On each one of these, we're going to create a parse command that's static. That means it's not, static means it is not a member of the class. It's just housed within the class, and it has full access to the class, and it can create these sort of like a factory function. So what parse is going to do for the Go command is it's going to first do that string split. So we want to go standard colon string hold on. So I eliminated all that stuff from here. Let me back that out. So we're going to create a vector. Basically, we want to do most of this stuff here. I'll just pull it out and take it over there. Go command. This is what we want to do. All right. This is going to be our line. We're going to get our command pointer. New Go command. It's not this though. Parse command is going to need to receive a game pointer. It's going to be a dungeon crawl game pointer, game, and a player pointer player, and these will all be the same. So this will be the game, and this will be the player, and then the words. But what we want to do also is pull some of this stuff down and find the room and make sure it's valid. A valid room. Well, no, we can do it this way. This is just going to parse the command. We don't want to do this here. We want to return our command. So this is going to move this responsibility for parsing this particular command to here. And now we can make a simpler kind of chain of ifs that'll look nicer and be easier to read. And we'll format those very carefully. This is still not the best way to do it, but this gets the idea across, and it's understandable. We will refactor these things over time. Let's go back to here now. We still want our command pointer. We still need this. Now what we're going to do is we're going to start some checking here. We no longer have a command string. We'll just send the entire command out to this. All right. So what we're going to do is we're going to say if go command parse this comma underscore player comma command else, and we will have the ability to assign, well, what do we want to do here? Command pointer temp equals null pointer. We'll say temp equals the parsing. If temp equals null pointer temp, well, temp equals other command colon parse this underscore player comma command. We don't have that yet, so then we'll say else if null pointer equals this, if temp equals null pointer, we can continue that. If temp is still equal to null pointer, we can do another command. Okay, and then finally, if the command so what we'll want to say here is else command equals temp. Else equals temp. And if we want to be purist about it, we would do this. And we'll add these other commands in, but this will be a way to test this. I got extra parentheses on here, and we'll create some other commands, other to command. So we'll create some other commands, and we'll very carefully chain them together this way with the creation of this using this parser. So then it'll come down, and if it's a null pointer, if it's not a null pointer, it'll execute the command, print out any errors that come from executing it, and finally say it's an unknown command if necessary. Otherwise, it'll execute the command. So let's see if this actually compiles and runs. It compiles, so we can go store. And it went to the store. We're now in the store, and we can say go start, and we're now in the start. And if I go back to, where is it? This one, start room, buy stuff. What did I do wrong? Room. Let's open up a room. Room has this. That's why. Underscore description. This should look a little better now. It'll have a name and a description and the exits. And it should have exits. So go store. Exits inventory. Exits then inventory. There's no exits. Go, start room. Okay, that's looking a little bit better. We still don't have a quit command. Maybe we should make a quit command. How much time do we have here? Oh, we're only 8 minutes in. Okay, so let's make, well, let's do that. Let's make a quit command. So for the quit command, we've got access to the game. So so it'll be very much like the go command. We'll do the parsing, but what we'll do is we'll just take the go command .h and we will copy it and we'll paste it. No, can't do that here. What we'll do is create a add new item. We'll call it the quit command. We'll delete the quit command CPP. There it is. We'll delete this. Delete it. And then we'll go to our go command. Where is it? There it is. And we'll just copy, we'll copy all this here. Into the quit command. We'll fix this up. It's got to be, go back to our go command. We need these includes. We need the public, yes, the public command. Go command, we need this. Same constructor, except we'll rename it to quit command. So this needs to be quit, same as the name of the class. Excuse me. Go command. We just need the error. We don't need room. Well, we don't even need the error really, because so we'll put this here. We'll get rid of room. We'll have error in place. We don't need, I don't know how that got in there. We don't need that. We don't need room. Well, we can get rid of all this execute for now. We don't need that. The split. Go command. Command.h. Split's fine here. Command.h. Quit command. Why doesn't it like my split command? Split. Go command. String. We've got string. We do. And command. Split. So that's odd. Why would it dislike split? Well, QUIT, unknown command quit. That's because we're not processing it, but we actually have to have the execution of quit. So what's quit going to do? If it parses it out, I don't know why it's not liking that. But the go command didn't need that string handlers. But it's got the same stuff coming in. I don't get it. I don't know why it required that. It didn't seem to require it to compile. Something weird going on. So there was our parse should work. It's going to create a quit command. It doesn't need words. Quit command doesn't actually need words. One, it doesn't need this string room. So we can get rid of that. We can get rid of that. It probably doesn't really even need the player. But we have to send it into the parse for consistency. Yeah, we'll leave it the player because we'll call quit on what we'll do is we'll call quit on the player. So when it comes to execute here, we're going to go underscore player pointer quit game. Game doesn't have a quit. Dungeon crawl game have a quit. Find, create room, eval command. So we need a quit function. Void quit. I'm going to say underscore running, runn. So that's in game, and running, that's game.cpp, game.h, protected, private running, that needs to be protected, so that we can go over here to our quit command and go underscore game pointer quit, and then in game.h, nope, dungeon crawl game.h quit running equals false, and that should actually quit the game. And then what we have to do is go to our dungeon crawl here, and we'll pull this out and we'll call it quit command. Quit command parse else command equals temp. If temp equals null pointer, temp equals quit command. Then it comes down to this one. Now the quit command should work. Should work. If it compiles, it does. Let's try it. Quit. Quit. Quits the game. So let's make sure go works. Go store. I'm in the store. Quit works. And we could print something out related to that. So that's how we add a game. We kind of refactored it. We can make these kind of neat and simple now. We can easily track them. They're not nested ifs. They're just one if after another. But we want to simplify that down so that it's clear what's going on here. The steps, and then we can put comments on here that says this particular block here determines if it's the go command or the quit command or whatever other commands that we do. So I think that's enough for this video. Thanks for watching. I hope you enjoyed it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button. And if you want to get notifications when I upload videos, hit the notify button. Thanks, and I'll see you in the next video.